Okay, so let's have a go at working out the centre of gravity of this whole shape. So the shape is like so. So it's a book with a water bottle on the end, and we're trying to find out where the centre of this, the centre of gravity of this thing is. So it's not quite the same as the centre of area as we did last week, and we've now got 3 dimensions in mass rather than 2 dimensions and only area that we had last time. Okay, so but the idea is exactly the same. The process is the same process as we did before. So we need some information. So let's say that this water bottle is 750 mils. It's not quite full, so we'll call that 700 grams. So we'll say that the water bottle is 0.7 kgs, and we'll say that that book looks to be, I don't know, what do you reckon? 1.5 kgs, something like that. We'll make the book 1.5 kgs. So the block can be 1.5 kilograms. The book is about 200 mils, I guess, long. Got the water bottle just about at the end, so we've got the water bottle 10 millimetres in, and the diameter of the bottom of the water bottle might be 40 mils. And the water bottle is central on the book. It's on the middle of the book. Okay, so the question is, where is the centre of gravity of this object? And it's the same as we did centre of area. So when you did centre of area, I hope that the first thing that you would do is the start point, find the origin, okay? And if it's got an axis of symmetry, you can put the start point on that line. There's no point in having to, when we know that the centre of this thing is going to be somewhere down the middle. Yep, because everything, if I cut it in half down the middle, both sides are exactly the same. So I don't have to worry about starting in a corner and going, oh, how far across do I have to go? It's obvious, it's the middle. Yep. So we're going to put the origin at the middle. And the question that we're asking basically is, how far along do I have to go to get to the centre of mass for the whole thing? Okay, so find that tipping point. Okay, so that's the first step, like Glenn said, is to say where you're going to do your measurements from. What's the second step you normally do? Second step, break the area up into basic areas. So which basic things do you want for this one? It's not hard, is it? Yeah, a cylinder and a book. So it's the rectangular bit, the rectangular prism, and the cylinder. Yep. And then it's exactly the same as you did previously. So instead of working with area, you work with mass. So we need to know the shapes. We've got A and B. This time we want the mass, and we want the distance. Technically, it's a weight. I guess it's a force that's causing it to turn, but I assume that if one end of the book is in Earth's gravity, then so is the water bottle. It's not likely to be. Yeah. G is going to be the same across the whole thing. So that'll come out in the wash. Okay, so for shape A, I've told you the mass is 1.5 kgs. And for shape B, I've told you the mass is 0.7 kgs. Okay, so for the book, where's the centre of the book going to be? How far away? 100 mil. Yep. The whole thing's 200. The centre's obviously in the middle, so X is going to be 100 mils. And what about the centre of the water bottle? Where's that going to be? Any takers? Any good numbers on that? 170 from Harrison. Where'd you get that from, Harrison? Yeah, so he did the smart thing and went to the end and worked backwards. Yeah, so 10 mils plus 20 mils to get to the centre of that. So it's 30 mils in from the back. 200 take away 30, 170. Agree, that's exactly right. So the centre of the cylinder is in the middle of the cylinder. Yep. And then we just do the normal multiplication trick. So that's going to be 150. That's going to be 70 and 49, 119, I think. Someone's got a calculator somewhere that can tell me if I'm on the roll or not. Add that one up as 2.2. Add this one up as 269. And then the normal thing, X bar is all those things divided by the total mass. So 269 divided by 2.2 is 122 and 3/11. So we'll call that 0.3. So we're not working in fractions. 0.3, that'll be fine, and that's going to be in millimetres. Okay, so without the water bottle on it, without the water bottle on it, you can push the book to halfway, and just when it's at halfway, so that's pretty close to halfway, and it's staying, and a bit over halfway, as soon as you get past halfway, it tips and it goes. And what I'm saying is if you put the water bottle on it, assuming that all of our estimations are correct, we should be able to get 120 millimetres sticking over the edge before it tips. So we should be able to get considerably past halfway, and a bit more maybe. Yeah, it's just unbalanced about there. So if we've done our estimations right, then this would be 120 millimetres sticking out here, and the other 70, 80 millimetres back there, if our estimations are all good. Which looks about right. Yep. So you can work out where the tipping point is, and that's what we mean by the centre of gravity. Okay.